Hey guys, Professor Doney here. We're in the middle of talking about circuits, specifically DC or direct current circuits, which means the current flows in one direction. And we're using the conventional direction, meaning the current will go from the positive to the negative. Okay, as part of circuits we have things called resistors. We've talked about those. Resistors are used to control the total amount of current that flows around a loop or in a continuous path or inside of a circuit. And even though the connecting wires do have a little bit of resistance, that is very low compared to these resistors or these devices or bulbs or heaters or whatever we plug into the circuit. Those connecting wires have low compared to that. So we're looking at resistors. We usually use capital R in the equations, and typically they're drawn like this: straight line, these are sawtooth, and it has some number of omegas for its resistance. Now what I'm going to talk about in this video real quickly is we pick up a resistor in lab and we look at it, and it has it's a little tube and around a wire, and it has some colored bands on it. Now typically if these are 4-band ones instead of 5, which I'm told are used for military, there's going to be 3 that are sort of grouped together and then one by itself here on the end. The one on the by itself, or offset a little bit, is either silver or gold in color. Okay, and the other 3 are sort of from the Roy G. Biv, the red, orange, yellow, green, blue, violet, and then black, brown, gray. Now I couldn't show black on here, so I'm making this one a red, brown, brown. So how do we read these? Well, we look at the chart that would be in the lab, or you can find online for the standard resistor color code table or chart. And what we do is look at the first digit is a red. A red for the first digit equals a 2. Brown for the, I'll make it BR, for the second color band. For the second digit actually equals a 1. And then the third band is also brown. That is also going to be a 1. But for the third digit, what it's telling us is that we add 1 0 to the end of these, which is 10 to the first. So the way we build the resistance of this resistor, so we can read these color bands instead of having a written down number, is that the resistance of that resistor is going to be a 2, a 1, there's a second digit, and then we add 1 0 or multiply by 10 to the first. So 21 times 10 to the first, that means it'll be a 210 ohm resistor. Okay, that's the value. Now what about that last band over here? The last band, just going to pick a different color to do that. The last band here is, for us, is going to be a silver, and the silver, if we look up, is telling us sort of the error or the percent variance, and that can be 5%, 10%, and I don't have that code in front of me. Let's see if I can find one. I don't think I have that code in front of me to tell me what that variance is, but it's you know, usually 5 or 10%, something like that. We don't need to worry about it in the things we're doing, but it tells us how much it'll vary plus or minus that, so it could be. So that's what it's supposed to be. If we want to double check to see what it was, what we would do is get a multimeter, and a multimeter is just a device that measures lots of different things, and we'd have the multimeter here, or the dial, and we would set it to ohms, and we'd take one lead and put it and touch it there. We take the other lead, which could be black if that one's red and this one's black. We take those leads, touch those, and it would read out some number of ohms, and we could check if that 210 is actually correct. So that's how we would read resistors, using the color bands. Again, that's for lab to help you out there. So hopefully that works, and we'll see you in the next video where we're going to continue using these resistors.